Hello everyone, welcome once again to another video related to machine learning by Slide Scope. And in this video, we are learning handwritten digit recognition with logistic regression. So this will be a handwritten digit recognition, which will be a supervised machine learning task that we will perform. And the algorithm that we will apply here is logistic regression. So on our machine learning playlist in our account, we have uploaded the theory of logistic regression. We have uploaded some basic examples of logistic regression. And in this example, we will do an optical recognition task. The data set that we are going to use here is load digits data set, which we can get from scikit-learn. And in this data set, you can see if you will load this data set, it will load and return the digits data set, which is used for classification problems. Each data point is a 8 by 8 image of a digit. So if you see here, this is a digit. Okay, you can see it's a 8 by 8 image of a digit. This is 1 written, this is 2 written, maybe this is 3 written. So it is 8 by 8 image of a digit, and each data point, as you can see here, is 8 by 8 image. There are total of 10 classes, and there are like from digit 0 to 9 there are total of 10 classes. That's why there are 10 classes, and sample plus per class is 180. Total number of samples are this. So I will provide a link to this datasets description also. Now this data set is a copy of the UCI ML handwritten digits data set, which you can see here, and you can see data's characteristics and everything, and you can see various details here. Now what we will do is we will simply get started here, and first thing to do is to import the data set and see some examples. So the library that we will use to import the data set is sklearn.dataset. We will import load digits. Okay. So in sklearn there are many data sets that you can use for practicing machine learning, basic machine learning. And then matplotlib inline will make sure the graph is plotted in within the notebook itself. And from matplotlib pyplot we will import plt, which will help us in plotting graphs. So now we will create a variable called digits, which is load digits. So this we are creating an object of the load digits here, and now this object can access the images that are there in the data set, the samples that are there in the data set. We will use plt.gray. So plt.gray means obviously a gray image will be created, and for I in range 5 we will use mat show. So that means we will try to show 5 examples here. So for I in range 0 to 5 we will show image I. So what will happen here is I will take 0, 1, 2, 3 and 4, and 0, 1, 2, 3 and 4 you can see. Suppose we want to see 9 or something, so we can write it similarly. So if we will write I in range 6 comma 9, you will see some examples of 6, 7, 8. Okay, so there are different ways that you can use here to create these images, and this is what you can do to first understand what is there in the data set. Now let's try to understand what directories are there in the data set. So it is giving DESCR, data, we have features name, frame, images, target and target names. So if we write digits dot data 0. That means we want to see how is 0 written. You will see this array. So this output is actually an 8 by 8 array. Here you will have total of 64 data points. It usually looks like this. So first line, second line, third line, and this is basically 0 written. Okay. uh, when we see colors here, so each element in digits dot data 0 corresponds to the grayscale intensity of a pixel, with values ranging from 0, which is black, to 16, which is white. So you can imagine a total black background here, and 16 is white, so 15 white, 15 white, something like this. If you go like this, you will see something like this. Now if you want to see 0, you can print it also. Let's insert a code cell. So we will reshape it to 8 by 8. So we will create an image, use digits dot data 0 dot reshape to reshape this grid into 8 by 8, and then using cmap gray we will print it. So this is 0 basically, you can see. So this is what it is doing. It is representing images in form of a data. Images, you can represent the images mathematically. Since it is a grayscale image, hence we are using numbers from 0 to 16. Okay, 0 means black, 16 means the brightest color or white, and everything in between will be some shade of gray. Next is to train our logistic regression model. So from logistic regression, from sklearn.linear model, we will import logistic regression, which we have done so far. In linear model, we also have linear regression. So we can use logistic regression here. And then we will create the model object using the logistic regression class. Then, as we discussed earlier, we use the train test split from model selection, where we break the data into two parts. So our X here is digits dot data. Okay, this is all the inputs, so which you can see here, right? Digits dot data. So this is our data, and target is all the target variables, and here we have target names. So what you can do here is, in digits you can see what is data, what is feature name. So this is something that you can do. For example, digits dot decr. So if you want to see the description, so you will see what this data is displaying. If you will write feature names, so it will show you all the feature names, pixel, these are the feature names like pixel 0607, something like that. You can also see the target names. So target values will be 0, 1, 2. These are arrays, and these are target names. So your target names are yeah, these are target name from 0 to 9. These are the numbers. And if you will write target, you will see a big array that is from 0 to 8. It has values, different values. So this is what we have. So if you will see data, then you will see an array like this, okay, where each array represents a digit, okay, and so it is a supervised data set. So first we are getting a matrix like this. So you are getting a matrix like this, and its target will be written as 0. Similarly, there will be another matrix where 1 will be written. Okay. Similarly, let's say 1 will be written and output will be 1. So we are converting all the handwritten digits into the handwritten digit images into 8 by 8 grids. So we are breaking the images into these 8 by 8 grids. That means total of 64 blocks we have, and we are coloring these blocks with black and white or gray images to understand which color is there in which block, and this way our uh, model will understand if 40 people have written 0. Here you can see we use pre-processing programs made available by NIST to extract normalized bitmaps of handwritten digit from a pre-printed form. From a total of 43 people, 30 contributed to the training set and different 13 to the test set, right? So many people have written this in their handwriting, and that way the model will try to understand how have 30 people written 0. Okay, and on the basis of that, if 30 if another person writes 0, then model will try to predict that person's handwriting character with whatever data that model has to learn, or whatever data model has learned from, and then after comparing it will give some output that you may have written 0, you may have written 1, or something like that. So this is what we have, and we will use X train, X test, Y train, and Y test to split our data set into various sizes. So train test split has been discussed in other videos, also in our machine learning playlist, so you can watch them to understand. And since you are coming from that series part, so you must be knowing this as well. Next thing is to fit the model with training and testing data. When you will with training and testing data, so let's run these things first. So from here we have imported train test split, and when we will fit the data, so it will tell us logistic regression is created. Okay, now we will try to predict the model's score. On different runs it will predict a different score. So in our case, when we fit our model with training data and we tested the model with 20% of samples, because we kept the test size as zero point 0.2. Test size 0.2 means we are using 20% data for testing and rest of the 80% data for training the model. So model has predicted correct answers for 97.5% of the cases. Now let's see, we are giving values from 0 to 5 to the model. So it is predicting it correctly, because we know that from 0 to 5 there are numbers from 0, 1, 2, 3, 4. What if we say 0 to 10? Predict digits from 0 to 10. So it is predicting 0, 1, 2, 3, 4, 5, 6, 7, and 9 correctly. If we make it 100, obviously it will be a big prediction, but it is still based on the samples it is predicting. The order is 0, 1, 2, 3 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see for yourself that it is predicting most of them correctly. Somewhere it is making mistake like here. So this is something, that's why the accuracy is 97. Now we will create the confusion matrix, which is a way to evaluate the performance of our model. And we to create accuracy score or to create confusion matrix or use them, we already should have y test value, and x, then we will also create a predicted value. So tested value is something that we will have, or the actual value is something that we will have, and then there will be a predicted value, so it will be compared. So when you will run this, and from this, so you will see a confusion matrix like this. So from sklearn matrix we import the confusion matrix, and then we create an object of the confusion matrix called cm with two parameters, that are y test and y predicted. So y test we already created with train test split, and y predicted we got from model.predict x test. So for all tested samples, we have the actual test values and we have the predicted values by the model. And confusion matrix will create a matrix with the help of these values, and it will give us this kind of matrix. Now let's understand this. So we have got this array. This is confusion matrix for classification task that it involves a model trained to predict digits from 0 to 9. Okay, so count the lines here. You will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So 0 to 9. The confusion matrix summarizes how many times the model correctly or incorrectly predicted each class or digit. So when we run predict versus actual data, predicted data versus actual data, so it will predict, sometimes it will predict correct value, sometimes it will predict wrong value, and since it's a supervised data set, we already have the correct values and we can tell which values are right or wrong, and that's why we can evaluate our model's performance. Here rows represent the true classes. Okay, true class, true class, true class. Column represent the predicted classes. Predicted class, predicted class, predicted class, this. Okay. So rows represent the true classes and column represent the predicted classes. Each cell I comma j indicates the number of instances where the true label was I but the model predicted j. Okay. So you can see 3800. True level was I and model predicted J. Example, in the cell 00, that means in first cell, we have 38 written. Okay. The model correctly predicted 38 instances of the digit 0. Correctly predicted 38 instances. Okay. 1 comma 5 is 1. So you can see 1, 0, 1, 2. So 1 comma 5 is 1. So this is 1, 0, 1, 2, 3, 4, 5. The model mistakenly predicted one instance of digit 1 as 5. Okay. So model has mistakenly predicted one instance. So that's why 1 is written here. Okay. So so as you can see here, rows represent the true class, column represent the predicted class. This is for 0. Okay. So in case of 0 also, sometimes it has predicted it has 5 one times. In row 5, so let's create a simple explanation because this was asked by many students to explain this. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So this is 0, 0. This is 0, 1, 2, 3, 4. So here in row 0, 38 zeros are correct and one time 5 is predicted. So someone wrote 0 like this, but model thought it is 5 written. Similarly, someone might have written 1 like this, model thought it is 1 written, it is 5 written. In 2, you can see model has predicted 27 times correctly and no other value. Similarly, in 3, 40 correct. And this is based on the sample size. Like in sample, there might be, different values randomly selected. So even in 6, you can see sometimes 6 has been predicted as 1. So this is what this is representing. Okay. Similarly, you can say 9 comma 8 is equal to 1. the model mistakenly predicted 1 instead of digit 9 as 8, you know. So this is 9 comma 8. So this is what is happening here. Diagonal entries ij represent correct predictions. So class 0 38 are correct, class 1 43 are correct, class 9 27 are correct. So you can tell that these instances are correct. Okay. Off diagonal entries, the off diagonal entry should be 0, but if they are not 0, that means this is the model misclassified one instance of 0 as 5. The model misclassified 1 instead of 6 as 1. Okay. Now the model performs well with most predictions along the diagonal, that is correct prediction. Misclassification are sparse and mostly involve a small number, that is 1. Mostly it is 1 written somewhere. The classes 2, 3, 4 and 5 are especially well predicted with no minimal misclassifications. Using the confusion metric, you can also compute metrics like accuracy, precision, recall, and F1 score. For example, to find accuracy, you can write sum of all diagonal elements divided by sum of all elements. So this will give us the accuracy score as 87.75%. Okay. And you can also compute class-wise precision and recall. So in the previous examples, we have already done those things like accuracy score and all. Now we will use Seaborn as Sn, and we will try to create a figure of size 10 comma 7, and we will use the heat map to print this. Okay. So you can also use a heat map to print your metrics, so that you can understand for which class model was able to predict it correctly. Okay. And this is the same matrix being represented here. You can see some values like here it is 4, you know, here it is 4. That means 3 and 8 are mistakenly predicted. Here it is 2. So sometimes 3 is also predicted as 9. And this is what uh, this logistic regression is doing. So most of all, it is quite accurate. That is something that we can conclude from this example.